inside the $8 billion Bering Strait Bridge, the proposed mega project connecting the USA and Russia, full engineering concept.
For centuries, the 53-mile gap between Asia and North America was an impassable barrier of ice and storm. The dream? To link the hemispheres. A superhighway connecting New York to London via Moscow. Geopolitics aside, the economic potential was too vast to ignore. The treaty of the century was signed. But the enemy is the environment. This is the Bering Strait, where sea ice crushes anything in its path.
Survey ships had to battle 10-foot thick ice sheets just to map the ocean floor. The good news? It's shallow. The average depth is only 50 meters, making a bridge theoretically possible. On the Alaskan coast, permafrost was the challenge. The ground literally moves as it thaws. Computer simulations tested the nightmare scenario, a massive iceberg collision at full drift speed.
The Tyne Diomede Islands, sitting in the middle, would become the crucial stepping stones for construction.
In Siberia, a city rose from the snow, housing for 10,000 workers brave enough to build the impossible.
Construction could only happen with a constant guard of nuclear icebreakers keeping the lanes open.
Specialized divers used heated suits to survive the sub-zero waters for mere minutes at a time.
Before the pillars could rise, the seabed had to be leveled. Massive dredgers scoured the rock.
The foundations weren't poured on site. They were built in warmer climates and floated north on heavy-lift ships. Day one of the structure. The first massive caisson was flooded and sunk, anchoring the bridge to the crust.
Standard pillars would snap. These used an inverted cone shape to force ice upwards until it breaks under its own weight. Underwater, special marine concrete filled the hollow base, turning it into a solid, artificial island. It was too cold for human hands. Robots tied the steel reinforcement bars, working tirelessly in the blizzards.
Finally, a gray stump broke the surface. Man had planted a flag in the Bering Sea.
To prevent tipping, massive rock anchors were drilled 100 feet into the bedrock. The first winter test. The ice came, hit the cones, and shattered. The design held.
To prevent ice buildup from climbing the pillar, heating elements were embedded in the concrete skin.
One by one, the line of gray giants marched toward the international date line.
The caps weighed 5,000 tons. The world's largest floating crane, the Sleipnir, was brought in for the lift.
Over this distance, the curvature of the Earth matters. Lasers ensured the tops were perfectly level.
Surprisingly, the foundations became artificial reefs, attracting Arctic cod and crabs.
Work wasn't continuous. When the polar lows hit, everyone evacuated. Nature still ruled here.
Salt spray is corrosive. The steel was galvanized and coated in epoxy to last 100 years.
On the shores, massive gravity anchors were poured to hold the tension of the suspension cables.
When the ice was too thin for trucks but too thick for boats, hovercrafts were the only way to commute.
The most symbolic moment, connecting the U.S. island of Little Diomede to the Russian Big Diomede.
Big Diomede became a transit hub. A massive customs station was built on the rocky outcrop.
This is the Ring of Fire. Massive hydraulic dampers were installed to allow the bridge to dance during earthquakes.
Open decks would freeze instantly. The design called for an enclosed aerodynamic tube. The spans arrived, prefabricated steel tunnels, ready to be lifted into the sky. The lift took 12 hours. A single gust of wind could have swung the load and destroyed the crane.
High-altitude welders sealed the joints.
At -40 degrees, the steel had to be preheated to prevent cracking.
For the spans between pillars, a launching gantry pushed the bridge deck forward like a sliding ruler. It's a double-decker, high-speed rail and pipelines on the bottom, a 4-lane highway on top. Wind here can reach 100 miles per hour. Angled fairings slice the wind, keeping the structure stable. Metal shrinks in the cold. Expansion joints capable of moving 5 meters were installed to handle the freeze.
The roof wasn't concrete, but a translucent polymer. It let in natural light while keeping out the snow.
Inside the tube, it was calm. Outside, a blizzard raged. The shield was working.
For the widest shipping channels, simple pillars wouldn't work. Massive suspension towers rose into the clouds. A spinning wheel traveled back and forth, weaving thousands of thin wires into a single cable thick as a tree trunk.
The keystone piece. The central deck of the suspension span was lifted from a barge in the treacherous current.
Vertical hangers transferred the weight of the road up to the main cables.
This wasn't just for cars. It was an energy corridor. Pipelines carrying Siberian gas to America were hung below.
And data. Cables carrying the internet traffic of 2 continents were laid in shielded trays.
As the sun dipped, the scale became apparent. A man-made line stretching 50 miles across the ocean.
Traditional gravel ballast would freeze solid. They used concrete track slabs for the high-speed rail. Continuous welded rail eliminated the click-clack, allowing trains to glide at 200 miles per hour.
Special low-temperature asphalt was laid. Even inside the tube, it had to withstand the Arctic chill.
Copper veins were strung up. Electric trains would run on clean energy, powered by wind farms on the coast.
With thousands of trucks passing, exhaust fumes were a problem. Giant jet fans scrubbed the air.
Daylight LEDs mimic the sun, keeping drivers awake during the 24-hour Arctic winter darkness.
A fire in a 50-mile tube is a death trap. Automated foam cannons were installed every 50 feet.
Mid-ocean pit stop. A service station and hotel were built right on the bridge structure near the islands.
The world's most advanced border crossing. Facial recognition scanned drivers without them even stopping. Robotic painters applied the final coat, a polar white designed to reflect UV radiation.
Future-proofing. A section was reserved for maglev trains, anticipating the next century of travel.
To ensure the migration of whales wasn't disturbed, sensors monitored the waters below 24/7. Outside, a whiteout. Inside, dry pavement. The enclosure was a triumph of engineering. The bridge had a nervous system. Thousands of sensors felt every vibration, reporting stress to the control room.
On the mainland, the approach ramps rose gently from the tundra, protecting the delicate permafrost below. West meets east. The bridge asphalt finally touched the Russian road network.
Exterior guidance lights were installed. For ships and planes, this bridge was a new landmark on the radar.
If all else failed, gravity drop lifeboats were installed along the span, ready to drop into the sea.
The heavy machinery left. The silence of the Arctic returned, broken only by the hum of the wind.
The paperwork was signed. The impossible structure was certified safe for humanity.
Opening day. A convoy of trucks from both nations lined up, engines idling in the cold air.
No politicians could miss this. The ribbon was cut, signaling the end of the divide.
History in motion. The first truck rolled out, carrying a cargo destined for a city 5,000 miles away. Beneath the road, the Peace Express hit 200 miles per hour, blurring the line between continents.
Passengers sipped coffee while gazing at polar bears and icebergs mere feet below them.
The weirdest moment? Crossing the date line. You literally drive from Tuesday back into Monday.
In the control room, the flow of global trade was now a series of dots on a screen.
Humans rarely go outside now. Autonomous drones patrol the exterior, hunting for cracks. The shipping lanes remained open. Massive tankers passed underneath, dwarfed by the steel giants.
At night, it feels like a spaceship, a ribbon of light cutting through the absolute darkness of the Arctic.
Tourism boomed. People traveled just to say they stood in the middle of the Bering Strait.
The world link was complete. You could technically take a train from Cape Town to Santiago.
Goods that used to take weeks by ship now arrived by rail in days. The supply chain was revolutionized.
The bridge became green. Turbines harnessed the fierce Arctic wind to power the entire structure.
Safety teams remain vigilant, drilling for the worst-case scenarios in the harsh environment.
Seasons cycle. The ice melts, the water turns blue, but the bridge stands constant. Nature adapted. Whales navigate the pillars just as they navigate the ice flues. The price tag was astronomical, 100 billion. But the trade it unlocked? Priceless. For the islanders, the edge of the world became the center of the world. A simple sign, "Welcome to Russia." But seeing it from a car with US plates felt surreal. It is a monument to human stubbornness, a refusal to let geography dictate our limits.
A golden spike at the midpoint marks the union, a handshake in steel. It paved the way for a new era of electric, autonomous logistics.
From space, it's a thin gray line, a thread stitching the planet together.
And under the Aurora Borealis, it is perhaps the most beautiful structure ever built. It wasn't built by one nation. It was a global effort, a Tower of Babel that actually worked. The Bering Strait Bridge. The impossible made real. The longest, most expensive, and most audacious project in history.
The road is open. Drive safe.